Input and output allow programs to interact with users. Many programs both read data and write it. So, a program may read data from an input device, operate on that data, and then write the data to an output device. A simple programming model for an I/O device is a set of registers. Some of the registers may be used to communicate data, that is, to send data to an output device or read data from an input device. Other registers may be used for status, about the operation of the device and when it's asked to perform a function. Many computers make use of memory-mapped I/O. That is, the registers of a device appear to be memory locations. For example, device 0 occupies this portion of the memory space. In order to read or write a register, the program reads or writes the appropriate location. The operating system helps keep track of which device occupies which part of memory. Programs need to be sure they don't interfere with the devices that are mapped into those parts of memory. Busy wait is a very simple form of I/O. This code tests a status bit in the I/O device and waits for it to change. When the status is set true, then the code reads the data from the device. This code does not make effective use of the CPU. The CPU spends a lot of time waiting for the I/O device to finish. Many I/O devices are considerably slower than the CPU. Interrupts allow programs and devices to operate concurrently. When an I/O device is ready, either to read more data or it's finished writing data, it will interrupt the flow of control of the program, and the CPU will cause a driver routine to be executed. Once the driver services the I/O device and finishes its work, it will then return to the original program, which will continue executing. The CPU needs to look for interrupts as it executes. So, before fetching the next instruction, it can check for an interrupt. If there is an interrupt, it will save the program counter and set the program counter to the address of the driver. It can then go in and execute. If there is no interrupt, it simply fetches, decodes, and executes the instruction that's pointed to by the program counter. Two mechanisms make it simpler to keep track of a number of different I/O devices on a computer. Priority determines which interrupt is handled first. Vectors determine which driver is used to service the interrupt. Here's a simple piece of code that looks at a variable that corresponds to the state of a switch. If the switch is on, it sets the LED to high. Otherwise, it sets it low. Serial ports are still used for certain types of I/O, and they provide a simple example of an input and output device. The interface logic used for a serial link is known as a UART, for Universal Asynchronous Receiver Transmitter. That has several registers that allow the computer to manage the operation of the serial port. Data is sent on the serial link using a start bit, a set of data bits, and then a stop bit. For an I/O operation, the computer may first set the mode of the UART, then send a character for writing. That character goes out over the serial line. When it's finished, the UART flags the status as being ready. At that point, for example, a character may be received on the serial line and read by the computer. Thanks for watching.